Hey everyone, my name is Lyndon Hillenbrand. We're at Cloudera HQ, and we're going to talk about Introduction to Hive. So what is Hive? What's the motivation and application that people are using Hive for? How does Hive enable Hadoop to act as an enterprise data warehouse? Talk about Hive and the RDBMS and how they can interact. Some of the components in data model and the metastore in Hive. Creating, loading, and analyzing data. And we'll also go through a Shakespeare example. So what is Hive? Hive is a data warehouse infrastructure built on top of Hadoop that allows for SQL-like queries against your data sets. Hive runs on the client machine. You submit a Hive query. It automatically executes several MapReduce jobs. They run in your Hadoop cluster, and you're returned with a subset of that data. It's very strong for three reasons. Number one is it allows business analysts, who may not be Java programmers, to access data sets in Hadoop using basic SQL knowledge. It appears to them as a relational table structure with partitions, buckets, and allows you to run these queries against all of your data sets within Hadoop. So what was the motivation behind creating Hive? Well, Hive was created at Facebook, where they have about 300 unique users per month on their Hadoop cluster. When this started, data was being collected nightly via cron jobs into an Oracle database. It was really overloading the database, and they had hand-coded ETL Python jobs running the analysis. So while moving to Hadoop, they didn't have the ability to write MapReduce for all these people. They weren't Java programmers. So they built Hive, a SQL-like interface for these business analysts. Now they were able to access the data and run ETL jobs hourly, daily, even weekly if they'd like. So now there's multiple variations of data analysis leveraging Hive. The most basic is where companies are moving their long-running aggregations to Hive and keeping their fast-running queries in a MySQL database. Hive is being used for predictive modeling and analytics, data mining, textual analysis, as well as customer-facing business intelligence. So how does Hive enable Hadoop to act as an enterprise data warehouse? Well, you have things like business analysts, engineers, as well as business users to access Hive through the command line interface and execute standard SQL queries. They can also use a Thrift application, JDBC, or ODBC applications to access the Hive server. So how does Hive fit with your relational system? Well, let's talk a little bit about Hive and its properties versus an RDBMS. So Hive is a schema on read. It's also very, very high latency. It's built to read entire table scans, large data structures, so it's really for heavy analytics and large aggregations. MySQL is geared towards fast-running queries. That's why when you load large aggregations or very heavy analytics in MySQL, it tends to downgrade and run very slowly. Where in Hive, that's where it shines. So the example I use is you wouldn't basically trailer a boat with a Ferrari, right? You use a truck. So for Hive, you would use a stronger vehicle, quote unquote, and MySQL would act as your basically race car for fast-running queries. Both of these have their own jobs, and they both end in a front-end application. So you can tie them together using Scoop, which is an import and export feature. So what are some of the components of Hive? You have the shell, which allows you to access the interface. It supports web and JDBC clients. You have the driver, the compiler, the execution engine, and the metastore. The metastore is where the scheme is held, and all of the data files locations within HDFS. So the data model for Hive, it's basically broken into three things. The first is tables. That's your high-level structure. Tables are created with typed columns, those being your ints, floats, strings, booleans. You can also create it with a list, basically a map function. Then there's partitions, which are parts of tables. They optimize your table structure for data access, your quote-unquote slicing and dicing of your data. And you have buckets, which are hash partitions within ranges. These allow you to run sampling strategies on your data. When you're analyzing, let's say, a terabyte, 5 terabytes, 10 terabytes of data, you don't want to run a Hive job just to see if you can get a sample and see if your job's running correctly. So you create buckets. It's very similar to SQL. Then there's a metastore. The metastore contains the namespace for your set of tables. It really holds all the definitions, all the partitions, and the physical layout and the structure of your Hive warehouse. By default, it's created by Derby. It's a Derby database. You can set this to be MySQL, and that's really what the best practice is today. If you want your users to access your MySQL database, and you want to have multiple users access your Hive warehouse, you need to make sure that in HDFS, your Hive warehouse is set to writable for all users. So what's a physical layout look like? The warehouse is a directory in HDFS. It's a subdirectory of user/Hive. And your tables are stored in the subdirectory of the warehouse. Partitions are stored in the subdirectories of tables. It's a very simple structure within HDFS. Actual data is stored in flat files. It can also be stored in text files or sequence files as well. So using Hive. We're going to take a look at starting the shell, creating tables, generating, loading, and selecting data, a most common frequency analysis. We'll look at joins, which are Hive's strong point, manipulating tables, partitioning, bucketing, and finally UDFs. So starting the shell, it's very simple. You add Hive to your class path and type Hive in your terminal. There's a screenshot on the slide of exactly what it should look like. You can do this through your standard DDL operations, very similar to SQL. There's show table, create table, alter table, and drop table. You can load data, partition, and bucket, but we'll start with create. So creating tables in Hive, it's very similar to SQL. It's almost exactly the same syntax. It's create table, table name, and then the parameters you want within that table to create your columns. In this example, table is called foo, and the two columns are ID, which is an integer, and message, which is a string. You can format the row based on different types of formats. You can format it based on comma, tab delimited, new line, and you can specify that just after the create table statement, as shown on the screen. There's several different storage formats. The popular ones are sequence file and text file, and there's multiple sureties you can leverage. Those being regular, lazy, HBase, or regex. What are Hive's data types? There's several basic primitive types. They leverage Java's 4 main integer types, and they act exactly the same. It also has a tinyint and a smallint primitive type. Double, string, and boolean are your standard operators. Then you have the complex types, which are array, map, and struct, where struct is a primitive type relation, just like a bag. So there's two different ways to load data into Hive. You have the ability to load data from HDFS resident folder or from the local file system. There's two simple commands. The first one, to load data from an HDFS file, is load data in path, the HDFS file, into table, and then your table name. The second is the same, you just include the local operator in the load data in path command. So what about partitions? Let's say you have web logs and you want to partition them by day. You add the partition specification, let's say by date time, just after the end of the create table statement. So if you want a bucket, the most important thing is to set hive.enforce.bucketing property to true within your Hive config. And basically you can create buckets by adding the clustered by statement onto the end of a create table statement. In this case, we're bucketing the ID into 32 buckets. Buckets are extremely important for sampling data, as I talked about before. If you have an extremely large data set, you're going to want to bucket and test. So for this one, we're going to randomize 5 buckets out of 32, which means it will randomly distribute your data set into these 32 buckets and then pick the data that falls into bucket number 5. So views are very similar to SQL. There's a concept where you can create a virtual table and define that in the select statement. You can examine these views once created in the show table command, and you can modify and examine query types using views. However, views are read-only and will not affect the actual table stored in HDFS or locally. If you want a drop table, it's just like SQL. It's a simple command, drop table, and then table name. If you want to delete a partition, it's alter table, table name, drop partition, partition specified. So let's go through an example. We're going to do a most common frequency using Shakespeare and then the King James Version of the Bible. So let's create our tables. And you can follow along on the screen and use the examples. We're going to create the table Shakespeare with the limited fields terminated by a tab sequence. And then you can type describe Shakespeare to show you what the schema looks like of that table. Generating the data, we're going to run a Hadoop job on the examples jar to generate the Shakespeare frequency file. Once this file is created, you can load data in path right from Shakespeare into HDFS. So once it's loaded into your Hive table from HDFS, let's take a look at the select statement. You can start with a basic select star from Shakespeare. Semicolon, that'll give you all the results in your Hive Shakespeare table. You can use a limit command, just like SQL. Let's limit it by 10, you can get the top 10 results. If you select star from Shakespeare, where frequency is greater than 100, and sort by ascending limit 10, you'll get the top 10 results where it's greater than 100. So the Hive select count. When using Hive select, you select a count of 1 from your table and group by whatever frequency you'd like. You can put the explain command in front of select, and that will actually show you what's executing on the query underneath the covers of Hive. So let's create the King James Bible dataset, because we're going to do a word count and join on these two datasets. This example is also in the Cloudera VM. So joining these tables. Joining is one of Hive's strongest points. It gives you the availability to do an outer join, an inner join, or even a map join. So joins can be extremely complex in standard MapReduce. So in Hive, it's a simple command that you can add in one line, whereas Java it could be 60, 70, 80 lines. So let's calculate the frequency of the King James Version Bible and see what words appear in both the Shakespeare text and the King James Version the most. So the create and import statement. We want to create a new table we're going to import to. So we create the KJV table, which is going to hold the King James Version of the Bible. Now we have two tables, Shakespeare and KJV. We're going to import the data into the new table, so import the Bible version into the KJV table. Let's create a merge table. That's going to allow us to actually store the merged files once we join them. So we're going to insert overwrite the table merged, and then select what we want to join. So then you can do a Hive star select from merge limit 10, and then I'll give you the top 10 results of the join. Now an important piece here is the insert overwrite. When you overwrite something in SQL, you normally are just replacing the table that's there. Or you're inserting data into the table as a subset or an append. In Hive, it will actually remove the file and insert a new table into what your select statement is asking for. So it's quite a tedious operation. However, you just have to keep in mind they're actually replacing the table and it is doing a lot of work under the covers. So what's the most common intersections? If you run the select clause here, you'll find exactly what the limit is of the top 20 most common words appearing in both texts. So that's it for the example. The project status of Hive is that it's an open source Apache 2.0 licensed project. It's an official sub-project of Apache Hadoop. There are several committers at Facebook and here at Cloudera. The current version is 0.8.0, and you can get Hive from the hive.apache.org site. You could also check out the Apache Wiki, and there's quite a bit of functions that go with Hive and UDFs. You can check them out on the Apache Wiki as well. Thank you very much for your time today.